This next portion we're going to talk about graphing of functions and their inverse. We can find the graph of the inverse by locating the mirror image on the point with respect to the line y equals x. Here's our line y equals x right here. Closer related. Okay, I'm off the line a little bit, but so if this is my g of x function, this particular one right here, I can do a mirror image with respect to kind of like if I folded it along this dotted line y equals x to find my inverse function over here. Okay, so same thing. Here's another example with respect to our y equals x. I'll do a better job of trying to stay on top of it. That's our y equals x. So basically if I folded my paper in half at that point and I knew my k of x, I could fold it in half and then align it so that I could know my inverse of k inverse of x. Okay, so this is just showing us a graphical depiction of how our inverse and our original function can relate to each other in respect to this y equals x. Now, we're going to be given a picture and asked to evaluate, and this is slightly a little bit blurry, so I'm going to go through and name some points on here. So for example, my original function, this is the point 0, -2. This is the point 2, 0. This is the point 3, 2. And up here is the point 4, 4. And let me find one down here a little bit closer. It looks like -3, -3.5 approximately. Okay, so if that's my original function, all of these are asking me about the inverse. So I'm going to say let that be p of x. The questions are about p inverse of x. So if my function is 4, 4, the inverse is actually for this one would be 4, 4. But what's the inverse of 3, 2? 2, 3. Good, so let me just plot my inverse. So 4, 4 is the same because it's the same numbers, obviously. The inverse of 3, 2 is 2, 3. The inverse of 2, 0, so we're here now. The inverse of 2, 0 is 0, 2. The inverse of 0, -2 would be -2, 0. Inverse of -3, -3.5 would be -3.5, -3. Okay, so then we're going to -3.5, -3, and then we have that. So I'm going to try to give myself a rough sketch of P inverse of x. So the red is our inverse. The red is what we're actually going to pull all of our answers from. It says when the x value is 4, what is the y value? So basically, when I go over to 4, 1, 2, 3, 4, and arrow up to the red, what is my y value? So then I come back over and that y value is a 4. Let me move these out of the way. By now you should have written them down. Okay, so let me do that again. Go to this is P inverse of x. When the x value is 4, so I come to the x-axis of 4 right here and an arrow up to the red line, come back over and say the y value is 4. So let's do this one. Go to the x value of 0. Well, that's right here. X is 0. Go up to the red line and tell me where it crosses the y-axis. It crosses at the y value of 2. Alright, go to the x of -3. Well, that's here. So start here and I'll come to -3. Go down and name that. It looks like it's going to be -2. So let me do that. So go when x is -3, go down to the red line and then arrow back over to the y-axis, and that's where I said I get -2 from. And then our last one right here, go to the x value of 2, which is here. Go up to your red equation and then arrow back to your y-axis, and that one is going to be 3. So in this case, they gave us the original function, and I decided to write all the ordered pairs down, and then I did the inverse by simply the inverse of 3, 2 is the ordered pair 2, 3. And I created my inverse graph by switching the domain and the range over here. So then I created this red graph because all of my questions, all of the evaluations they asked me to do were based on my red graph, which is the P inverse of X. Write that more clearly. P inverse of X. Right here, this red one. So that's where I answered all my questions. And to evaluate this, you go when X is 4, they want to know what is the Y value. And that's how you would approach something like that.